Hello, my name is Chris Fernandez. I'm a solutions engineer with Keysight Technologies. This is the third video of a series for bringing up the Freedom boards from NXP i.MX. RT1186. I did two videos already. One was pretty much the physical components of it, changing jumpers and configurations on the board itself to get it working. The second video was about writing and building an image into the box. And now we're in the third portion of it that we're actually going to be changing, configuring QBV and testing it. So right now the board is turned off. I'm going to turn back on. So by turning this back on, the board should be at the level where we just left off on video 2. So I'm going to just do a reload here. So at this point here, the board is just coming up, and you can see port 0 here. There's no PTP yet. So in order for us to get QBV working, so PTP has to be on. So I have a configuration here already. One is the scenario here. So I just have the master port and the slave port here. Port 1 and port 1 and port 2 for my mini, and I have PTP on both the main 0. So I'm gonna bring protocols up. So hopefully PTP will come up and we can go from there into more of the QBV. So the PTP return is now it's on. It's set default to true. So you can see here that port 0 is domain is master, which is connected to here, right? So port 0 is master. It should become a slave. So let's wait a little bit because it should be the slave. Okay, so they changed the role. Now it's a slave where it should be, and this one is the master. So everything is according to PTP is okay, right? So if you look at PTP drill down here and you look at the statistics, we can see that one is port is the grandmaster, the one is slave. We see the offset here around it's very close to 0, and we can see the path delay here. It's 150s, around 150s, which is closely related to what the DUT is reporting. And you can also see that on the slave side, we can see that the master clock ID here is the same as what we are advertising for the master. So the bridge is working as correctly. So at this point, PTP is resolved, so we can move on to the QBV part. So at this point here on the screen, you're going to see that it doesn't stop scrolling through the GPTP information and port information. So at this point, you have to hit insert, and this we're gonna bring you to this bridge type of prompt here. So this is now our configuration. So if you want to get information about what commands are available here, you can do help, and it prints all of them, or you can do specific ones. For example, if you want to do help underscore config VLAN, for example, then the commands that are available for VLAN will show up here, and so on. So in order for us to do QBV, there's two parts of it, right? So one is on what we expect to be the gate information and how we're going to configure the traffic. For that, we're going to go read a little bit on the user guide. So this is part of the user guide, and the user guide tells me that for this RT bridge ports, which is our case here, you can see here the VLAN priority, which is on top here, corresponds to different traffic classes, right? So the priority 0 goes to traffic class 1, and then you can see that priority VLAN priority, right? 1, it's traffic class 0, and so on. So this gives you a little bit of the mapping itself from VLAN priority to traffic class in the system itself. So with that in mind, we can do a simple experiment here where if we close all the gates, PTP should stop working, right? Usually what's going to happen is that PTP traffic doesn't come in with a VLAN. It's but and then internally it's assigned to a VLAN and usually gets set to priority 6. So if you look in this table here, priority 6 is my traffic class 4. So let me see if I can have a table here so we can identify it a little bit better. So I created this table here, which is a little bit easier to understand. So now we're saying that the GPTP traffic gets classified with VLAN priority 6, right? So that in terms of traffic class is actually 4. So that means that if I go in here and I want to kind of kill PTP, what I can do is I can close all the gates, right? So by closing all the gates, I'm expecting that PTP will actually stop working, because the PTP packets that are usually going into VLAN priority 6 are going to get classified in traffic class 4, and it's going to be closed, and the PTP will go down. So the command to initialize or configure QBV on, it's this one here. So it's QBV set 3 is my logical interface. So I have 3 interfaces on this board. One of them is internal, so we don't really count. And there's another one that is also part of the configuration, but it's like a port that doesn't exist or something like that. You gotta read a little bit more, but from what I understand, ports 2 and 3 is the ones that I'm playing with. So it's the port number, logical port number 2 is my ingress, and my egress port is number 3. So that's why I put 3 in here. So this is the base 0. So this here is my cycle time, and then on that cycle time I have only one gate that has the 00 indicating that it's closed all the time for the duration of the cycle. So this is now I enabled the scheduler, and I can see that my PTP now goes down because I have no more if I go here, I see that let me clear the stats here, and you can see that now all the PTP messages are being blocked by my gate being closed at the egress, right? So now I have to understand of like, okay, so which gate or which traffic class does it mean that is my gates coming from, right? So I can play around with it and see which traffic class it's being my PTP is. So I can go one by one, or I know it should be traffic 6, so I can cheat. But let's say, for example, I know that let's see if it comes in on traffic class 1, right? Was right here, which is 02, 02, and nope, PTP is still broken, right? Now let's see if it's coming on traffic class 0, right? On this right here, it's on, so it should be 01. So I can open the gate just for 01, and nope, everything's still broken, right? So I can go down this list here, and what I'm going to find out is that VLAN priority 6 is the one that I'm interested in. So if you go down all this down in the list here, nothing's going to work until you get to this, where you set the gate to 10. To hex 10, right? So that should bring my PTP up. That means that the untagged traffic from PTP internally, it gets classified in traffic class 6, which what it should be. In VLAN priority 6, PCP 6, which is mapping to traffic class number 4 here for us, which is 10. So I can continue doing this until I find which one is actually open for my GPTP, because right now there's no traffic that I'm sending, it's only PTP traffic. So I can go down my list here. So is it 40? Nope, it's still gonna, PTP is gonna be broken, right? So it's not traffic class 6. Right, it's not this. So I'm here now. I did 02, 01. Now I can go and I'm gonna keep going just so I show you. Now I'm over here opening this traffic class here, 7. Is it traffic class 7? Nope, it doesn't get classified there. So I can keep going. So after that is traffic class 2, which is 04, 04. And nope, PTP still broken. I can still not receiving any messages. Everything is being blocked, right? So I did the way to 04. Now I can do 08. Still gonna be broken. 08. So now I'm still broken, right? So I'm not receiving any packets. I'm down here now. I'm already, I tried all of these here. Everything else is closed except this guy here, which is traffic class 6, which is my VLAN priority 5. Now the only solution is going to be if I do this. Now if I set this to 10, so now I'm talking here, I'm talking traffic class 4, which is my VLAN priority 6, which is what I expect. This is gonna, as soon as I enable this, I open the gate here. This now I should start receiving PTP messages down here, and PTP will come up just like it did right now. So now I know that what made my PTP work was actually this traffic class number 4, which is mapped to VLAN priority 6. So that's the correct behavior that I was expecting, and the correct behavior that I was hoping for, right? So now that we know that the VLAN priority 6 is the one that's used by our GPTP traffic, when we configured actually a gate list, right? We always have 6 always open, so PCP 6 always open, right? So for our testing here and for the configuration that I did 4 gates, right? Cycle time of 1000 microseconds. Each gate is going to be 250 microseconds. And what I do and how I get them is like this. So for gate number 1, I'm saying that priorities from 0, 1, 2, and 3 are, and 6 is open, right? So that's going to be the hex. So you do the hex of 02, which is the first one, right? 02, 01, 40, 80, and the 10 for the 6, and that gives you D3. So we put that into my configuration here. So it's QVB set for the logical interface 3. That's the beginner 0. This is the cycle time 1000, or I think this is in nanoseconds here. And yeah, the numbers are in nanosecond. And so it's going to be 1,250,000 for each. And then I'm just, the gates that I want to be open, I can just sum the hex up for and grab the value, right? So this is 14 for gate number 2, 18 for gate number 3, and so on. So I'm opening up the gates on this way. So number 6 gate, the gate 6, sorry, it's always going to be open because that's my PTP traffic and I don't want to interfere with it. Okay, so we're going to set this QBV configuration on my gate, on my DUT. So I'm going to copy this here and put it in here. So that's part of it, right? So now the other part is actually adding VLAN to it. So right now the board does not expect any VLANs. So we're gonna add VLAN 100 for the ingress interface and the outgoing interface. So we do this. So we do VLAN update 2 and 3. And to make sure that that actually works, we can do VLAN underscore dump, and that gives you an idea of what is being tagged and used and so on. So I have my VLAN 100 here that I'm going to be using in my traffic. And another thing that I am going to add is I'm going to do an update on the forwarding database, and I'm going to make sure that this MAC address here that I'm using on my traffic, coffee 01, is going to be sent out on VLAN 100 on my logical ID 3. So this here is going to give me the ability, even though there's only 2 ports here, so I'm assuming that he would, because he usually this is for switches that have more than one port, but in our case it's just one port. So it doesn't flood, doesn't happen all the time, right? So, but in this case, we're just going to be saying that you know how to forward this traffic that I'm going to be sending in. So this is the port this is the MAC address that I chose in my traffic, and we're going to go over the traffic before I send it out. And same thing here, we can do FDB dump to make sure what is configured there. So you can see that a couple things are configured there. And the one that I'm sending is going to be this one here, a coffee 01. It's going to be forwarded to forwarding 3. All right, so in terms of traffic, in terms of configuration on the Mini, so I have the Mini configuration here. I have a Windows version associated to my Mini. I have 2 ports. And the traffic that I created is one single traffic item that has 4 flow groups in them. And we're going to take a look at the individual flow groups. So I'm just going to go through this. So I created this raw because I don't have VLAN on my scenario. So I had to create a raw and add VLAN to it. So looking at the packets, I have 4 packets, one for each gate. You want to see it that way. So for this, this here is traffic that's going to hit gate number 1. And I know that because I have VLAN priority sets to 0, 1, 2, and 3, right? So those 4s are going to go to gate 1 and VLAN ID 100. Again, this one is for gate number 2, and that's priority number 4, right? So it's the same VLAN ID for everybody, but VLAN priority 4, and this is for VLAN priority 5. That's my gate number 3. And the last gate is gate 7. My VLAN priority 7, VLAN ID for everybody the same. And that should be hitting my gate number 4, right? So if you think about the cycle of 1,000 microseconds, you have the first gate open between 0 and 250, second gate from 250 to 500, and so on. So this is the configuration for the traffic itself. I'm not going to change that. Now the only thing that I have to add to my configuration on my DUT, on my i.MX network here, it's going to be under global settings, under traffic option and global settings, to tell the clocks to synchronize. So I'm sending traffic at exactly 0, like at the top of the at the top of the hour, say. So the traffic is going to come out on exactly 0. So I have to tell my my Ixia here to kind of schedule my settings based on the clock. So 0 time is actually going to be when I send 0 traffic. So traffic 1 and so on. So that's the only configuration I have to do here. And the other one is inside of flow groups, or inside of the flow groups itself, I have to tell on the rate setup. The first gate, there is no delay. The second gate, there's a delay of 200 microseconds. In order to get there, the gate is going to be open, right? And this one is going to have to wait 500 microseconds. So when it gets there, the gate's going to be open. And same thing for the last gate, and so on. So we have everything set here. We can just hit finish here. We're going to track over the VLAN priority. And if you want to look at the preview traffic, so you're going to hit here, and you're going to see that traffic number 1, or flow number 1 here, has flow group number 1 has 4 flows, 1 for each VLAN priority. Since the gate number 1 has 3 priorities, right, or 4 priorities, 0, 1, 2, and 3. This has 4, 5, and 7. As you can notice here, I'm not using VLAN priority 6, which is usually reserved and not used during the testing. So I'm going to finish this here, and I'm just going to hit send traffic. The other thing that I did forget to show you is the MAC address that I'm using here that I did an update on. But let's see if I can still show here. Let's see. The flow group packets, the Ethernet destination. So here, this is the A coffee 01. That's this MAC address here that I'm using to forward traffic. So under flow statistics, we can see that we have 7 6 VLAN priorities. 6 is excluded. And the first one here is for the first traffic item, has 4 of them. And then so this is gate number 1, gate number 2, 3, and 4. And to see if everything is working, we can look at a couple things here. One is the latency. So the latency is going to be the same for everybody here because everybody is being sent at the correct time. So when they get there, the traffic is open, like the gate is open at that point. So traffic is just going to flow through. That means that the latency for everybody is going to be the same. And you can also see here under the absolute timestamp, you see that the first 3 here, or the first 4 flows here, are always coming in at 002, 002. The second one is 252, and then 502 and 752. So everything is working as designed and as configured. Everything is working great, even on the NXP, and we're sending the correct traffic, so everybody's happy, right? So let's say now, how can you say that this is actually working? Well, one way of doing is to make sure that the traffic is no longer following the rules, right? So let's say that, for example, we can pick, let's pick the traffic item number 5 here, or VLAN priority 5. And for that particular group, if we go inside here and go back into my rate setup, this one here, we're delaying 500 microseconds, right? So we're delaying 500 microseconds for it to start. So let's say we are delaying 750 microseconds. All right, so we are coming in exact time where that gate just closed. So the gate is going to be closed from 750 to the next cycle, which is 1000, and then it's going to have to wait another 500 microseconds before it opens again. So now what I expect to see is that a delay of 750 microseconds for only this flow here, which is my priority 5, right? So let's see if that's going to be the case, and that kind of will give us an idea if everything is working. So the NXP is going to be buffering that traffic and only allowing it to go through the next the next cycle. So we can look at that too. So let's see here. As soon as the traffic resumes, we can take a look at that. Traffic item here is just showing that everything that we're sending and receiving, we're not really losing any packets. The frames delta you see here is just a difference between the 2 CPUs. When you take a picture at the exact same time, you can think this as the in-flight frames that got counted on the way out but hasn't been received on the other side yet. It hasn't been counted on the receiving end yet. So this is not a problem. So let's look at flow statistics. Flow statistics, everything looks great. So we're expecting that this VLAN here should have a 750 microseconds delay. And let's see. Nope, it did not happen. Let's see what happens here. So maybe the my configuration did not get through. So let me check. Stop this traffic. I don't think I hit the correct command here. Let's see, under flow groups. That's still 500. I don't know why it didn't change. So press OK. I'm going to regenerate and I'm going to apply again. That was my mistake. I think I didn't press OK or finish or something. The traffic did not get applied. So let's check again before I send traffic again. So now I'm delaying 700. Okay, so now it looks okay. So now let's go back again and see the flow statistics. And as soon as it says 750, I'll feel better. But let's see. So everything is going okay. Oh, okay, good. So now now I'm expecting to see what 750 is. And another thing that we can check as well is the even though you're going to see 500 here in the microsecond level here, you're going to find that this flow is actually on the next cycle. See how the 2 flows above and below is between 820 and 820, and this is 821. That's because the NXP switch is holding that packet one more cycle before it releases into the next cycle. That's why we see the latency this much, and you see here by the numbers too. So that's two ways that we can tell that this is working as designed. So I hope this was a good video and kind of show you how to test QBV. There's still a lot to learn for myself included in this box, but the interface and everything that I saw from NXP is really good and it works really well as expected. The problems that we saw is user error, but the results are great, and this is a great tool to understand QBV and start testing. All right. If you have any questions, feel free to reach out. Thank you. Bye.